Hello folks, I am Ed Overstreet and welcome to the Night Sky Imaging YouTube channel. Let me get comfortable. I'm going to go through my workflow when I process RGB data with narrowband, and in this case I shot the Triangulum Galaxy M33. I did that back in October. For some reason all I did was run it through the weighted batch processing script, and I stopped. And I thought at the time, maybe or earlier when I was looking at the data, I thought maybe it was because the data didn't turn out very well. I did delete a lot of subs because evidently my guiding wasn't good. That's usually why I end up deleting a lot of subs. A lot of hydrogen alpha and subs, but we're going to process it, and I'm anxious and excited about being able to apply the new Spectrophotometric calibration tool to the combined HA LRGB data. So let's go ahead and head over to PixInsight and start playing around with it. We are in PixInsight, and here I have already loaded and changed the names for the luminance: red, green, blue, and hydrogen alpha channel. So it saves some time, but if I go to the directory, here's the master directory. Let's go back to October the 17th. I can see under my lights that I ended up deleting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, about 15 HAs. And since I took those at 240 seconds, my gut feeling tells me that the guiding was so bad that the stars looked so pitiful that I just deleted them. And but I did keep like 22, I counted, and so of hydrogen alpha. So I have hydrogen alpha, I have a mess of red. I don't know if I have, yeah, I have 125 red. I have 125 green, and it looked like I deleted 2 blues, so I have, there's 125 taken, so I have 123 blues that I've taken, and of the luminance, I have 100 luminance. The RGB were 60 seconds, and the luminance was 45 seconds. I took this with a camera gain of 200 and an offset of 50. Now, the reason why I bring that up, I just did a video on that, but the reason why I bring this up is when I looked at the gain in the FITS header for these images and the offset, it normally tells me when I shoot at 200 that the scene conditions aren't that good and I want quick exposures. So I sacrificed dynamic range and I raised the gain with the ASI 1600 camera up to 200 so that I could get by with 45-second exposures on a I think the stellar view is an f6 refractor, and I used a reducer. I'm at about f4.9, something like that, with the reducer. So it isn't a real slow piece of kit, but at any rate, that combined with a gain of 200 allowed me to get by and get some data. So if you look at the luminance, it isn't great. The red, the green looks better, and the blue looks really good, and the HA actually looks okay. So I'm not sure why I didn't process it. Maybe I did, and it was so ultimately so bad I just trashed it. But I don't know. That's a good one. I don't know what I did or why I did what I did. So let's look at this and see if we're going to be needing to crop this image before, as we start. That's one of the first things that I'm going to do. And I generally have some artifacts on the edges, just stacking artifacts. So I'm going to bring up the dynamic crop, and I'm going to bring this in just because. It'll show up later when I've combined these images if I don't. So I'm going to leave it at that, and I'm going to save this process. I'm going to go ahead and apply it to this image. So my luminance is done. And so let's bring up the red, and let's apply this to the red. And that's done. Now the green, and let's do the same for the green. And now the blue. And finally our hydrogen alpha. Okay, so I'm going to save this crop, and I'm going to call this crop M33, and that's just in case I need to come back and start again. I'll just use the same crop. Now what I want to do is I want to combine the red, the green, and the blue channel. I will not be working on the luminance channel until I have taken the RGB and the HA to the nonlinear state. And then I'm going to work on the luminance at that time. So let's bring up RGB, combine, which is channel combination. I saved the processes that I use most often, and it's easier to get to them, but if you are looking for this channel combination, you can go to process all processes and come down here to channel combination. In fact, all of these can be found under processes or under script utilities. So let's reset this, and let's take the red and let's put it in the red channel, the green in the green channel, the blue in the blue, and let's run it globally. And let's see what we got. Okay, got some wicked gradients where green and blue, probably relating to light pollution. So we can close channel combination. Now what I want to do is I want to add the hydrogen alpha to this, and then we'll tackle the gradient using the dynamic background extraction tool. So I'm going to go to Script, Utilities, LRGB, combination right here. NB narrowband and RGB combination is what this stands for. And so I want to, as my source, let me close this out. Should have done this already. All right, I want to rename this RGB, and I want to save this. And so I have RGB clone. Now let's open channel narrowband plus RGB combination. So my target is going to be RGB clone, And the only narrowband data that I have is HA, and I'm going to use that in the red channel. So I'm going to take the HA and I'm going to put that into the red channel. That's all I'm going to do, and I'm going to apply it. Okay, it's doing its thing. I'm going to close this out. I'm actually going to delete this clone. I really don't need it. I've got it over here. And here is my NRGB combination. So I have my RGB now and my HA combined. That's looking okay. And it's been drizzled 2 times. The kit that I'm using is the ZWO ASI 1600 camera, and I'm using it on a StellarView 70T triplet, and it's 336 millimeters, so I am really undersampled. And my stars, when you zoom in, if I didn't increase this image 2 times through drizzling, they would look very blocky, these small stars especially. So I've increased the resolution, I've increased the file size, and I've also increased the processing time by 2, if not more. That's the price you pay. There's some trade-offs. So I'm going to change the name of this now to RGB plus HA. And I'm going to make a copy of this. I'm going to store the original over here. And we're going to have to tackle this gradient because it's a doozy. I'm going to use what I call DBE edges. It's actually DBE with some settings that I stole from Sean Nielsen, who is a great YouTube creator for astrophotography. If you don't subscribe to his channel, I would recommend that you do that. He's got some tremendous techniques and ideas that I've incorporated in my workflow. Sean Nielsen with Visible Dark. So I would certainly look him up. In fact, I'll put a link to his channel. I'm going to select Resize All to increase the sample boxes, make them a little bit bigger. And I am going to move them on the edges, and when I'm done, I'll come back. By the way, as I move these, I'm going to move them away from bigger stars, but it's okay to have some stars in it. This is predominantly background that these samples reflect, and so let me finish this and I'll be back. All right. Now, I like using this when my target is in the center. When I have nebula that is all over the place, covering the entire frame, I don't always, in fact, I rarely use this edge approach. Now, I am going to apply another sample box here, 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 and here. Smooth this down just a little bit closer. And let's go ahead now and save this process because I'm going to be reusing it, and I'm going to call this DBE M33. And so let's apply it. And close this out. Let's stretch it again and see what we've got. See how long it takes to stretch it? That's better, but we still have gradient. And so what I'm going to do this time, and by the way, I'm opening up all of these options so that you can see what these settings are in case you want to use these same settings for your images. I'm going to change this to subtraction from division. I'm going to apply it again. Okay, I'm going to close this out. I'm going to move my DBE edges over here by edges, and so far so good. The data's not looking bad. I don't know why I didn't work on it. What we do have though is an enormous amount of noise, and yes, looks like some streaking going on. Well, we'll have to deal with that somehow, I think. Okay, so let's attack the noise. Now, I run the Russell Croman's star reduction and noise reduction, but I'm not happy all the time with my results, and part of that is I'm applying the full or a lot of the noise reduction to the extremes, and I'm getting kind of a plastic looking background. So I'm really aware of that, and so what I want to do is now that I've ran DBE is I want to make a clone of this. I'm going to call this HA plus DBE, and I'm going to save that and add to my workflow trail. And I'm going to bring up MLT denoise. That's what I call it, but it's actually multilinear transform if you go look for it under processes. But I call it MLT denoise because these settings work pretty well in the linear state to reduce noise. So here's the noise I want to tackle, and let's first thing I want to do is I want to create a real-time preview. And I want to unstretch the image, and so the white part of this, because this mask is inverted, the white part is going to have noise reduction applied to it. Everything else is going to have, it's going to have a spillover of noise reduction, but it's the protected part of the image. So I'm building this mask, and I do want to have some noise reduction in the galaxy area. So I'm going to, it's right now it's set, amplification is set at 95. I'm going to drop this down to say 60 and see what happens. I like that. And in fact, let's just leave it at 60. So I'm going to have some modest noise reduction applied to some of the areas of the galaxy that you really don't want a lot of noise reduction applied to, but I think this will work. If not, I can go back and pick this up because I have this copy right here to work with. Alright, so let's close this mask. Okay, I'm going to close the real-time preview, and let's stretch the image. And let's zoom in here and see the effects of this, and let's apply it. It's working. Again, everything takes longer when you drizzle ×2. I can't imagine what it would be like if I drizzled 3 times. I just wouldn't. All right, so there you have it. We've got some noise reduction applied, and let me go up here. This is before and after. Before and after. And I don't have a plastic looking image either. So I like it. All right, now we have our noise applied, so let's make a copy of that. Well, we didn't make a copy. We're supposed to. Still didn't. Did then. All I need is a fickle computer. All right, now it's time to apply some color calibration. I already know that there isn't any photometry or spectrophotometry information. I can tell because it would be at the bottom of the data in this review box, this preview box, as you move around the image, but there isn't any. So in order to add the important information that spectrophotometric calibration requires, we're going to have to run Image Solver, which I have up here as a process icon, and it's execute in a global context. First thing I want to do is make sure distortion correction is checked. I want to search for the coordinates M33, and we'll use this server and hope it works, and it did. So we'll use the triangulum reference, and now we have populated the RA and declination. We don't have the time. We took this in 2020, October 17th, about 11, let's just say 11 p.m., and which would have been 23. And the focal distance, okay, this is important. I need my calculator now. My telescope has a focal length of 339 millimeters, but I drizzled, so I have to multiply that ×2, which is 678. Do not forget to do that. And so everything else is correct. ICRS is the reference system. The online star catalog, I don't have that checked. I think we're good to go. So let's apply it. Okay, that worked. Let's check. And we now have our RA and declination information. So we should be able to run the spectrophotometric calibration tool without issue. So let's bring that up. Actually, before I run that, I still have a green gradient up here, and I'm going to bring up DBE again, and I'm going to make a reference box there, 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 and there. And that's where I am seeing it, and I'm going to give it a try. And let's stretch the image. I think that did more harm than good, so I'm going to go back. Let me delete this. I understand. And let's go back to where it was. I can live with that gradient. Okay. After I run the photometric calibration and we stretch the image, I may try running the SCNR and try to remove some of the green. We'll just have to see. All right, now it's time to bring up photometric calibration, and I used astronomic filters. I already have those saved in a process. I used the ASI 1600 camera, and I really don't know which sensor it is, but I'm just going to go ahead and use the ideal QE curve. And I probably should have looked up the sensor by going to the ZWO website, and but I didn't. We have the GA DR3 spectrophotometric catalog installed, and that's what's going to be used to solve both the color. Well, it's already been plate solved to solve the spectrometry. I can't say that word. And let's see, all we need to do is come up with a background for background neutralization. And let's just look at the green. Let's find a patch. And for lack of looking any further, let's just go ahead and put one there. All right, now we're going to find that preview, tag it, and we can zoom back out. And let's run this. All right, we have a solve, and my slope and my data plots look okay. So we're going to call that a success. Let's now stretch the image using histogram transformation. We can delete the preview as we don't need that any longer. Okay, I hate to remove the green with SCNR. I just went to the trouble of color calibrating this image, and as soon as I run SCNR, I'm going to affect all of the pixels color in some way. So out the window goes the accurate color rendering. So I want to add, though, that we ran SBCC. I want to make a copy and set this over here. I'm going to make another copy and I want to work on this one, but I want to see what the SNCNR might do with the green. Let's remove about, say 50% of it. I think I'm going to leave it there. It helped some, so I'll get rid of this clone and we'll apply it to our image. Nah, heck with it. It wasn't that big of a deal. Let's just go ahead and close it. Now we're going to take the image to nonlinear, so we're going to stretch it. I'm going to go to script and see how the easy soft stretch works. I have really liked some of the results from the stretching algorithm, and I already like this. As a matter of fact, I think it's dealt with some of the green better than I could have, much better. So let's run it. And I still have a gradient, but that's light pollution, and there's not a lot I can do about it. I could always darken the background some and dumb it down, but I doubt I'll try doing that. All right, we are at the point where it's time to start working on the luminance image, but first I want to change this name to non-linear and EZ stretch, so I'll know what I did, and we'll set this over here. Okay, let's now put this away. We'll come back to it. Okay, now it's time to work on our luminous layer, and so we can later combine it with our RGB. And the first thing we're going to need to do is apply the dynamic background extraction, and I'm going to use the process that was used when we did the RGB. So the same sample points will work here. And execute. Since we have one red box, we can't make a, if I tried to change it and execute it, it won't let me. So I have to shut it down. I don't know why it does it, but I just know it does it. Sometimes you don't have to shut it down, but if you do, you'll notice that your sample boxes are all clean. So I want to change it now from division to subtraction, and we'll do this the last time. I don't think there'll be a need to run this twice. All right, and close it down. Let's do a stretch, and there's some modest gradients, but that's fine. The background's going to be prepared really for the RGB layer. It'll be somewhat darker than that. Okay, now we're going to need to create three masks. We're going to need a mask that's going to be the point spread function. It isn't a mask, it's actually a sample of all of my stars. It's going to be sort of the average that shows the point spread of the star, and that will be used in deconvolution because we are going to deconvolve this image. And hopefully, after having done so, we'll have a more contrasty galaxy, and we'll have our stars will look just a tad bit tighter and sharper. Deconvolution isn't a sharpening tool. I'm told that over and over again, but the effect is that there is some, visually it looks like it is being sharpened. So however you want to take it. So the first thing I'm going to do is just make a clone, and this will be my luminance mask. So let's just go ahead and give it a name. And while I've got the luminance mask up, and before I forget, let's go ahead and do our star mask. And I'm going to use no, I'm not going to use the default. I drizzled this image, so this is a ×2 image. These are some pretty large stars, so I'm going to raise the large scale structure to 4, maybe even 5, and it's got some very small stars. I'm just going to take the small scale to 0. I'm going to leave the noise threshold alone for now. I may have to raise it, but let's see what our star mass looks like. Okay, the star mass looks fine. By the way, you can create your star mask on a linear or a nonlinear image. The fact that I pulled the star mask off of this linear image doesn't mean that this image needs to be permanently stretched or taken to nonlinear. If I run a stretch on it, it just brightens it, but I'll undo this, but it works just fine. And so we're going to park the star mask over here and close this, and let's go ahead and create a model star. And to do that, you have a couple of options. The first option is that you can open the process called dynamic point spread function, or PSF, and it's under all processes, and it is, I lost it right here. I have it saved as a one of the processes that I use most often. And what's important here is that you find some stars representative of your image. So let's start with over here in this corner, and it is a Moffat, and it has a value of, just pay attention here really just to the A column, because this will represent the layers of luminosity. I don't know if layer is the right word, but if this was 1.0, it would be too saturated to be of any value in creating a point spread function model. So I watched a video from Sean Nielsen again. I really like the work he does with Visible Dark. That's his website. But he suggests that this be 0.90 and or less. And then on the floor, this is the ceiling, and on the lower side, he feels like that the value should be 0.20 or higher. But if it's in the low 90s, I go with it, and we need 20 of these. And you may get one that appears, you may get a Gaussian, for example, instead of a Moffat. Just delete it. You want to have all of the same models. Of the models, you want it to be all the same. So either Moffat or Gaussian or circular, whatever you choose, whether it's Moffat 8, Moffat 6, just make sure that they're the same. So let's go down. Let's take another couple stars up here. That's 0.89. I'll take it. 9.4. I'm going to delete it. And just hit the delete key. Let's get this large one. It's 0.89. Oh, did I get it? No. It's 0.97. I'll delete it. Was that a Gaussian? Nope. Let's do here. 0.96. I'll delete it. They're real bright down here on this side. I need some though from here. 0.96 again. 0.95. I'm going to go ahead and keep it. Let's try one of these smaller ones. 0.92. It is under 1. Delete that one. 6.3. That's a doozy. We'll keep it. 88. Good. 91. I'll keep. 88. Let's go over here. I want to get stars from my corners. Because this is a real representation of my star field, and it's going to be used in the deconvolution process. That's too much. Let's try this one here. 0.19, kind of low. Try another one. 0.85. Overall, I don't know what gain I used on this. I need to get into the Fitzheader 0.61, but I bet I was at 1.15. Wow, saturated. It's a tiny one, 0.94. But I bet I was at gain 200 on this 1600 camera. Whoa, blown out. 9.5, too much. 9.6, too much. 9.5, too much. 2.6, keeper. 5.4, keeper. You can zoom in and do this. 9.2, I'm just going to keep it because. And 6.0, we'll keep it. Let's see, we're pretty much all around the table here. 5.6. 3.0. All right. When you have a fair representation from your star field, then just come over here to the camera and click on it and you're done. And I'm going to close this out. And this is my sample star. Now keep in mind, and this is a problem, this has been factored by 2 times because of the drizzle. And what I have found is that when I drizzle more than 1 by 1, when I drizzle 2 times, that I cannot use my point spread function that's created by the dynamic PSF. This probably will not work when I try to deconvolve this image. But I wanted to show you how you can, on a non-drizzled image, find the right stars to be used to model for your point spread function. So I'm going to go ahead and tuck this up here. In the name of time, I doubt that I'm going to run any illustrations showing the difference between this one and the one that you're about to see. But there's another option, and this too probably will not work on a drizzled image, but it will work on an image that hasn't been drizzled, and it is my go-to method for creating a point spread function. In order to get this, you're going to have to go to Script, Render, and go to the PSF image. And I select Moffett, and all you do is choose Evaluate, and if it's a drizzled image like this, again, I doubt I'll be able to use it because of the 2 times factor. And what I will ultimately end up using is the one that comes with the deconvolve script or the process. So, but I'm going to go ahead and create this just to show you how it's done. And then I'm going to show you where, while it's creating it, where you can go to download this feature script. So let's get it started. And I'm going to go to the website for, this is skypixels.at. And if you just go to skypixels.at, and I will put a link up, and then go down to scripts, you're going to see the scripts that have been created by this gentleman right here, Hartmut Bornemann. And these are the instructions on how to add these to your PixInsight script. And I am one of those that follow instructions very poorly. Usually raise the red flag, call for help, and now how do you install these? But I was able to do this rather easily, so you will as well. Here is the point spread function. This one you definitely want to download. You want to download the game script. We'll be using that today. You'll be want to download AutoColor. Now, what AutoColor does, it is Hartmut Bornemann's script for color calibration. So if you do not choose to use PixInsight's color calibration or the new Spectrophotometric color calibration, this does a pretty Jim Dandy job. I like the results. Are the colors the most accurate? I don't know. I really don't. I just know that I like the results when I use AutoColor, and I would have to think, given the work that PixInsight's done on the new spectrophotometric color calibration in order to reach out to the models and bring the correct colors back to your image, that's the most accurate. But the comical thing about me and processing is that I'll probably take the very accurate colors that are rendered by the new spectrophotometric color calibration, and I'll end up changing them as I work curves and the hues. So how accurate will my colors be when the image is finished? Good question. Don't know. So we'll head back to PixInsight, and you're going to see how slow this process is when you have drizzled twice. We've only done 14%. So I'm going to pause this while this completes. Okay, it's finished, and we're going to now select Create, and we're going to open up our other point spread function. Well, you can elect to view the stars that were used in this if you choose. Let me close that out. And we're going to click OK since we have our point spread function. I'm going to bring this other one up, the one we created with a dynamic PSF, and I'm going to drag this over to make them the same size. And so here are the two side by side. So this is the one by Hartmut Bornemann. This is the one that I created, and you can see that it's just they're as far apart as two PSFs probably could be. So I don't know if it's due to the drizzle, but I do know that I can compare non-drizzled images, and they're usually pretty close, which is a reason why I'll use the Hartmut Bornemann script, because it almost invariably gives me the results I would have gotten had I used dynamic PSF. So this is a drizzled image, and I'm going to have them if I need them, but I doubt I'll use them just from past experience, and I'm sharing that with you. Okay, so the last thing we need to do is prepare our star mask, and to do that, it needs to be nonlinear. So let's go ahead and stretch it quickest way to do that for me is just to go to the easy soft stretch, and I'll accept whatever it looks like and use curves to finish it off. So I'm going to run it. Now this is a mask. I don't care how much detail or how bright I might make this. I want a mask that's going to protect some of the galaxy from deconvolving, and it's going to and include some of the can't talk. I want a mask that will help the deconvolving of this image, and in order to do that, I need to brighten it some and darken the background. So I'll use curves to do that. You could use the histogram transformation tool, just as easy. Let's create a real-time preview, and I want to click here, and I'm looking at my curve, and you'll see this kind of a purple line moving as I move across. These are the brightness levels in this image. So we have some stars that were very bright up on that side. Down here we had some that blew that out, were too bright. I don't know where they were, but at any rate, but I need to know a reference point. So here's the core, and then here are the arms of the galaxy. So I want to, let's find out where the darkest parts are, and I don't know. Let's see where I want to move around here, and I want the darkest I can find. That's pretty dark right there. All right, so about right here is, I'm going to put an anchor point. I'm going to move that anchor point up, so I'm going to put it too far down. And about right here, I'm going to start dropping this just to affect the darks primarily and darken that background some. It looks like I pushed the brights up. I didn't. It just looks that way. And I'm going to put an anchor point here, and I'm going to bring this up because this is in my galaxy. So I'm going to apply this twice. That's close enough. So my mask is going to kind of protect the core, and I hopefully will, somewhere out here in the arms of the galaxy, I'll get some added clarity. We're going to find out. And so let me, if you ever find that you've lost access to moving your image around, just click on this arrow and it'll drop it down some. Let's close out the real-time preview, and let's put our luminance mask over here. Now let's open up our luminance layer again, and so far all that I've done with the luminance layer is I have ran the dynamic background extraction. So let's add our luminance mask. And so the parts that have been selected are the parts that you see in the brightest areas. Those are the parts that are going to get some work done on them. Stars, and I can tell my mask is pretty large. I probably shouldn't have gone to a 5 on the upper structure. I probably should have left it at about 3, because it looks like that I'm inviting some halos. That may have to be changed on my star mask, but let's try it. It looked fine when I did it. I don't need to show the mask. I'll go to mask and uncheck this, And so let's open up deconvolution, and right here, which you can also find under processes, all processes, and go down to deconvolve or deconvolution. Under de-ringing, you do have that checked. I'm starting out at 6. I'm actually going to drop that down to about 1500. The default's about 0.6, and I have the global bright set to 0.01. I'm going to drop that down to 0.5. That goes a long way. I have local de-ringing checked. The mask that I already knew I was going to create, star mask, has been selected, but if you haven't anything there, go to find your star mask and select that. So I've applied the star mask. I've applied the luminance mask. The only thing I need is a point spread function model. So what I'm going to do is I'm going to create a good size preview, because it's going to need enough real estate to create a good deconvolve picture for me to make my choices and change my options. And I'm going to create another preview and another preview from that. It doesn't matter if it's okay. And let's go back to this preview. And I'm going to start out by using external, and I'm going to bring up the PSF. This, with the larger caps, was done by using the dynamic point spread function that is part of the processes in PixInsight. So let's go ahead and let's do this on about 10 iterations and see what effect it has on our stars and background. If I've got the background dark enough, by the way, if you start getting this local divergence at iteration 2 message, it's a warning. It means nothing. Ignore it. That doesn't mean your settings are wrong. They could be wrong, but that doesn't necessarily mean they are. And as you can see, it takes time to run this. I'll probably ultimately run this at between 40 and 60 iterations. Okay, so this is a after. This is a before. This is an after. This is before. Forget the background right now. This is an after. I'm looking at the star before, after. And let's go over and move to our galaxy, and let's go before and after. Before and after. So it's added some detail, some sharpness to it, but again, I'm not a real fan of this let's do one more, before and after. Let's see. Where's my before? Here you go. And I'm really just paying attention to the stars, and again, it isn't that impressive to me. So all right, so we have on preview 1, we have the deconvolve as it's been with the point spread function that I created using let's get a preview back out here again. Using the dynamic point spread function. Having a hard time talking again, folks. Alright, now we're going to choose the star that was created by Hartmut Bornemann in his script, and that's by, and I know that's what it is because it's the lower capped point spread function, and it changed there. So let's run it, and we're going to run another 10 iterations. Okay, and let's zoom in, and let's go to the other preview and zoom in. So here is my star. Here is Hartmut Bornemann star. I'll say star point spread function model. Let's kind of get these about the same for both. Actually, I can just drop this on top of this. It'll be exactly. So there's that one, that one, that one, that one, and I really am having a hard time seeing the difference. I think his is much sharper, not much, slightly sharper. Let's get in even closer. Yeah. So that's mine, and that's Hartmut's. Okay, and now let's go to this one, and let's just go ahead and make this fairly large so you can see where it's not been done, where it has been done, where it's not been done, and where it has been done. I don't know, mine might be sharper. Golly, does it matter? They're pretty close. Alright, now we're going to use the parametric point spread function, and this is included in the deconvolution script. So your parametric PSF is going to be identical to mine, and so this is a one-size-fits-all type of a point spread. So let's drop it, and I can already tell you that I'm probably going to be using this one. And we're on 9, and we are done. Alright, so here is the model as created by the decom script. Here is Hartmut's, and there's mine. Let's back up. Mine, mine, not mine, the deconvolve script or point spread function, Hartmut's. Let's make these the same size again. And I tell you what, they're pretty close, all of them. I'm really kind of surprised that this drizzled image Alright, now let's do, let's back out all the way on these previews and see if there is a, back out again all the way. And let's just do this. So now we're looking at well, folks, I think I'm going to go with my star. So that is the one that I created with the large caps, and I'm going to go ahead and delete these previews. We'll just go to preview, delete all previews. And we got our masks selected, we've got our star mask selected, we've got the point spread function as it's been created in the deconvolve script. No, this is mine. Yes, this is with dynamic PSF. And well, if you can follow me in this one, good for you. I can even follow me. So we're going to change the iterations to we're going to try 30 and see how that looks, and I'll be back with you. Okay, it's ran, and let's get close and look at this over to the side. I want to get some bright stars and see. Yeah, there. Let's look at before and after. There's more detail clearly, and I like that, but I probably should have just gone ahead and I'm going to take the global dark down to 0.00000. So I'm going to run it again, and because the brightness around the star, it was created by just having it set at 0.0050, and that makes some difference. And so I spend 5 or 6 hours capturing this, and I don't want to rush the processing by doing something that I know, by not doing something I know would probably help the image. So I'm going to go ahead and I'm going to keep it at 30 iterations, and I'm going to run it again, and I'll be back with you when it's done. Okay, we have completed a run of 30, so let's close this out, and it's time to stretch this image. I need to remove the mask. I'll go ahead and keep these masks, and I want to make sure I save this project, and I save as we go along. What you don't know is I did this video yesterday. I'm having to do this pieces at a time because of my schedule, so I'm kind of squeezing it in between stuff I'm doing, and PixInsight crashed, and so I'm just redoing the whole thing. I don't like to edit videos. I can help it. I'm lazier than the lazy geek. So at any rate, I want to save the project before it crashes again. And I have two iMacs. It crashes on both, and I have a Windows computer. It crashes on that. You're going to have crashes, I guess. I know I'm not the only one having them. Can't be. Okay. All right. So I'm going to change the name of this from Loom Clone to Loom. And I'm going to change this and call this NL for nonlinear, because we're going to stretch it, and that's what it's going to be. Now, I've got my original loom, and my original red, and my original green, and my original blue, and HA, and the only thing they have in common is the crop. And then I combined the RGB, and that is what we have here. Then we added the HA using the utility narrowband and RGB combined. Excuse me. I had to pause and do that. Then we ran dynamic background extraction and then multilinear transformation for noise reduction on the image. Then we did the spectrophotometric color calibration, and we ran a stretch. And so this is cloned, and this is what we have so far. And all I am interested in doing with this is color. Nothing else matters. I don't care about detail. I don't care about size of stars. I don't care about anything other than color. I want the color to be good. That's all. I want the color to be good. I want it to be adequately saturated, and that's all I care about there. Because all of my detail, all my clarity, all of everything I hope to do for the finished image in terms of sharpness is going to come from my luminance layer. The responsibility of this is color. The responsibility of my luminance layer is going to be detail, color, etc. So let's stretch this now, and it will be non-linear. I'm going to go ahead and just use this, and wait a minute. I've already done it. I don't have to follow through with it. I'm going to manually stretch this because I want to get it the way I like it. All right, so let's bring up the histogram transformation. And I need a real-time preview. I want to make sure that I have Loom NL selected. And here it is. And I want a real-time preview to see the damage that's being done. And let's get this one. We can see it from corner to corner. Let's unstretch this image. And now let's drag this slider in the middle. Mid-tone slider to the left, and add some brightness. Let's apply it, and let's reset. Let's drag this slightly to the right. This is our dark slider. I'm looking primarily at this histogram here. I am going to end up probably with some clipping, but that's okay, to the extent that it's going to be a few pixels out of thousands. And let's drag this over, brighten it up, and let's apply that. Now, this histogram is going to end up running way over here to this wall on the very brights, the very bright brights. Let's reset it, and let's drag our darks over to the left, and it's starting to go up. If you want to look up here, I don't know how well you can see it, but it's starting to climb. So let's stop there, and let's drag this over. Let's stop about there. And I think we might go a little bit more. And we might end up, let's apply this, and then let's go back. So let's apply this. It's now let's drag this down. Just a little bit too much. Let's apply that. And I'm not so much interested in the background as I am interested in this galaxy and how it's looking and where this histogram actually is in the grand scheme of things. So the center of it is probably I'm happy with it. So I'm going to close this out. Let's see, we applied this? Yes, we did. Or did we? I don't think we did. No. All right, so it's applied. Let's close this out. Let's bring up curves. This is Curves Transformation Tool. It's also found in the processes, all processes, and Curves Transformation. We need a real-time preview, and so I'm going to check this, the brightness, and I'm going to put an anchor point there. I don't want that to be raised. Let's go out here. I want to put an anchor point there. I've got my galaxy about where I want it, but the rest of it can drop down, which is going to be my background. So my background's coming down. Let's do it incrementally. Let's do that twice. And I'm not really having any effect on the galaxy, although that's slight. I'm going to move this. That's good. That's good. All right, so let's close the real-time preview. Let's see what we got. I like it. So there's our luminance layer, and let's close that out. And I'm going to make a copy of this. I'm going to put this over here. And so here we go. Now, I'm going to close this right now. For right now, I'm going to come back and add some saturation to the color. All right, now I'm going to remove the stars from this image because I want to work on the galaxy and only the galaxy. So we're going to go down to Star Exterminator by Russell Croman, and I don't need this star mask. Where'd it come from? And we're going to generate a star image and unscreen. So let's do that. All right, it's done its thing. So we have our, I'm just going to call this stars. And we're going to rename this starless, which will be used later. And so let's put our stars, tuck those away. You don't need this. Actually, I want to make a clone, and I'm going to put our stars away up here, and I'm going to save the stars. I also want to make a clone of this, and that's my dog hacking behind me. That's Astro Dog. And so what I want to do now is I want to create a mask for my galaxy. So I'm going to go to Script, Utilities, and we're going to select the Game mask. And this too is a mask you can download from Hartmut Borneman's SkyPixel website, and I recommend getting this mask. We're going to add an ellipsis mask, and there it is. We just need to change its size. Let's go ahead and enlarge it so we can see what we're doing. And we'll bring it out to here. Here. I think it will cover the real estate we want to protect, and we want to work on both. So let's apply this. I'm going to select OK, and we're going to take this mask and we're going to apply it by dropping it on this bar, and then I can tell it's applied by the color. It's turned to a reddish brown. I think that's the color. I may use this again, so I'm going to take this over and put it with the rest of the mask we've been used so far today, or in the last 3 days when I've been making this video. I've been making this video off and on for 3 days now, squeezing it in during times I have a few breaks. Okay, so we have the mask applied, and we can take a look at it, and you can see that the galaxy right now is what I'll be working on. The rest has been blocked out, so it's going to be pretty much protected. I'll tell you what I want to do first. I'm going to invert this mask, and I'm going to bring up curves, and I don't need to remove show mask with a real-time preview, but I'm going to darken the background a little bit, but not the mask. And so let's do that. Not a lot bit, but a little bit. All right, that's good enough. And now let's take our mask and let's invert it. And so let's don't show it. Tell you what I am also going to do. I'm going to bring curves up. I could have done this a while ago by just inverting it, not having to do curves twice. And I'm going to bring this up a little bit. Not a lot bit. And I'm going to bring up saturation also a little bit. And let's apply that because I'm going to apply saturation a little bit differently. And let's close that out. All right, I just want to get my color right. Remember, the luminance is going to bring out the detail and clarity. Hopefully, that's the plan. So I'm going to keep the mask in place, and all I'm going to be working on is this galaxy, and I'm going to create a luminance layer. So here it is. I'm going to use right up here the CIL lightness component, and we're going to create this mask. Okay, and I just want to, it's called Starless L, and I'm going to use it one time, and that's right now. I'm going to set it there for use. I'm going to bring up the LRGB component, or combined. Where did I get component from? I'm going to turn off the red, green, and blue channel because I'm going to drag this luminance onto this layer, but only drag the saturation. And I'm going to bring this down to 350, and let's kind of zoom in on this and see what happens. So if you move this slider to the left, you're going to increase the saturation. I don't want to pick chrominance noise reduction at this stage. I'll do that when I combine the luminance to the RGB image. But right now, all I want to do is add saturation proportionately to the areas that will be the best affected and most affected. So let's drag and drop. This takes a little more time with this. All right, I like it. Let's do it one more time. Okay. I don't think I'll do it again. I like that. Now the reason why I wanted a mask is I really didn't want to add any saturation to this background, and I removed the stars because I really don't want to apply any more saturation to already very colorful stars. There isn't a whole lot left to do with the stars. I like how they've turned out. But I did want to work on this galaxy, which we will later combine with the stars. In fact, we're about ready to do that. So let's close out LRGB combination. I like the saturation of this so far. The only other thing I might try doing is bringing up the saturation tool itself. I have already set some points in this process. I'm going to click on the blue right here and see where, and I'm looking at this, and I'm checking to see when I click on this blue where that blue is, and it's right here. So I'm going to put an anchor point about right there, and I'm just going to bring this up. I'm going to click on the real-time preview to see the effect of that, and let's bring it down some. And I want to bring up this kind of brown, and let's find that if I can get it. It's right there. It's a red. So I'm going to put an anchor point there and there, and I want to bring this up. And let's bang on that a couple times. I think one time is good enough. And let's close that out. All right. So we are finished with our galaxy. Saturation wise, we can remove this mask. And let's go ahead now and combine our stars back with our mask. So I'm going to open up stars, and I'm going to minimize this starless and actually just bring it over here. I won't use that again. I don't think. But do we want to have a star reduction? These are the red stars that we have, our hydrogen alpha stars that are part of the core of the galaxy and in the arms of the galaxy. They really turned out good. But the color looks good. I think I'm just going to leave this alone. And let's go ahead and bring up Bill Blanchard's star reduction tools. If you do not have these, I would recommend going down to one of the videos where I show how to add them and how to use them. But we're going to bring, I believe I'm going to use the method 1, and I'm going to leave, if you want to lower the value to reduce even more stars, you just lower this 0.15 to say 0.10. It opens, and Bill has it set initially to 0.15, and I'm going to leave it to 0.15. But the math has already been created, and it's going to reference this starless image, and it's going to create an all new image with the stars combined. So let's drag and drop. All right, that looks good. Now I'm going to minimize that. I'm going to minimize that stars. I'm going to change this now to M33 and close out that. And I'm going to change I'm going to change stars to set identifier to just stars. Now that you don't have to do any of this. I just am anal about having my processes in order that I use them in case I want to come back in next year at this time and working on this image and see how I did something. I want to be able to see it and the effect, just how I'm made, I guess. All right, this looks pretty good. It's going to change a great deal when we add the luminosity mask to it, but it's time to do that. So let's bring up our LRGB combination again, and this time let's see, where is our luminosity mask? Is this what we're using? Yep. Nope. Got a mask on here. Let's remove that. So that's not what we're using. We're using our nonlinear mask. And so we're going to drag this into there. We're going to uncheck red, green, and blue. We don't need this any longer. We're going to add just a smidgen more saturation. We're going to use chrominance noise reduction. And no, I'm not going to add any more saturation. Let's go back. I think I got it pretty much nailed down. But I'm going to go ahead now and apply our luminance mask. Fingers crossed. All right. Looking good, guys. Of course, it's all subject to what you like. And in the absence of, we've applied no noise reduction yet. I think I have my color the way I like it. And I definitely have a colorful star field that's not overly done. So I'm impressed with that. I probably could have removed more stars with Bill's star reduction, and then probably applied some morphological transformation to my luminance image, but I didn't. That's okay. I could do that now, and as a matter of fact, I think that might be a pretty good idea. So let's close this out before we apply any more. Not applying any noise reduction yet, but let's select this to 5 to this icon, which is the diamond structure. And we want interlacing 1, iterations 4. We're going to use the morphological median. That's fine. And let's drag and drop. We might have used all right, I think I did a nice job too. Could have used the morphological erosion or erosion minimum. That would have removed more stars, but that's good. I like it. Now, the last step for me in this image will be to bring up Russell Croman's noise exterminator, and I think I'm going to drag this down to about 50, maybe 60. I don't like to overdo this. I get a background that looks so smooth. It's like plastic, and I don't like that look. In fact, it's happened in the past, and I take it into Photoshop and I add grain back. Never thought I'd be adding grain to my astro images, but I've done that, and it has a real good effect. It's a uniform grain. It doesn't give that noise look. I kind of like that. But let's bring it down to 50. We can always add some more. Put a touch of ACDNR on it. And let's keep our detail. Let's bring this up to maybe 20. And let's apply Russell Croman's noise reduction. All right, we can close that out. I don't think, let's zoom in. Perfecto, not too much. Not too much, just right. Yeah. Great. Good job, Russell Croman. All right, there isn't anything else I would probably do to this image. I wouldn't know what else to do to the image. I don't want to sharpen it any more than it already is. If I did, I would use this sharpening tool, and I would start out with these settings in the second and the third layer. I might lower them to like 0.1010 to sharpen the second and third layer. And this is the multilinear transform. This is the very tool that I use for smoothing in the linear state when I first started the processing, but it does a good job of sharpening. In fact, I'm just going to take a look at the preview to show you what I'm talking about. Bingo. Didn't have a mess. But it will sharpen stuff up. And so I don't like it. I'm not going to do it. But it is a great sharpening tool. If I was going to fool with it, I'd probably end up changing this to 0.050. But I don't think this image needs, in my opinion, any more sharpening. Let's remove this. The only other thing I might do if I really was a glutton for just looking for something else to do is there are some halos around these stars I don't really like, and if you go to the script utilities star halo reducer, you need a preview first, and we pick a preview, say right in here, and we make it, it uses a kind of a horizontal preview. And then we go back up to script utilities and down here to star halo reducer. And you can set in this case we've got red. halos, but it's pretty much RGB all along the line that I would want to affect. And then you just build a mask that's based on, we got dogs in our yard. And I apologize for Astro Dog. He's back there guarding a house at our window. I'm in an upstairs room. This is my observatory. This is where I connect to my permanent piers and equipment that's out in the backyard. Okay, let's see. But here's where you set the radius of your star and what have you. But I'm just going to leave everything well enough alone because that becomes a trial and error thing, and it does create a new image for you with the halos affected by whatever extent you make your selection. So, with that being said, I hope everybody has a good day. I'm going to save this M33. We're going to remove this dew flocker, and I'm going to save this as a TIFF file, and that's the end of that. And talk to you later. Hope everybody has a great holiday season. If I don't make a video between now and Christmas, right now it's the 8th of December. We have 17 days until Santa. Between now and then, make sure you spend some time with your family. At age 78, I wish I would have, in retrospect, spent a lot more time with mine. Have a great evening, day, morning, whatever it is in your neck of the woods. Catch you guys later.